So thank you guys for being here. I drew this graph on the board, like I said, and it would be awesome if you could take out something to write with, something to write on, and draw it yourself as well. It might be a little hard to read, so I'm going to talk about the important points that are there, and some of those characteristics. But I'm going to back myself out of the video a little bit so you can see that. Okay. So draw a set of axes. Label scales for dragon tails. Let's make that scale 1 and 1. Make our numbers a little bit easier to read. And I just want to do this one. I want to work through just one problem together so that the practice that I put on Canvas on this announcement as well, but it's sitting in an assignment, it's called 1.1 practice. That should go a little bit better if we take today to just work through this one problem together. And that's it. So I'm hoping 15, 20 minutes, and then I'll send you on your way. Okay, so you got an arrow here on the left going up and out forever. Probably the next important point is probably that one. All right, I know there's a point right here, but nothing really changes at that spot. We're just kind of cutting right through it. But this one at -2, 0, that x-intercept at -2, that's a good one. -1, -2, there's a point right there. 0, -1, that's where we hit the y-axis. 1, 0, next x-intercept. And there's a little glare from the light, not much I can really do about that though. And then you got this point right here at 2, 4. So 2, 4 is where that one is, where it takes a turn and starts to head back down again. And so you've got this point, which is kind of stuck in that glare. That's at 3, 3. There's a point right there where this graph kind of comes down to that and then heads back up. And then heads all the way over to this last point. There's no arrow there. It's just a point. That's at 5, 5. Okay. So put that sketch in your notes. And then I'm going to back myself away from that graph so you can see all the things that we do with that. All right, let's go through everything we've done in 1.1. Min, max, x-intercepts, y-intercepts, all that good stuff. So here we go. I'm trying not to break anything while I do it. Okay, now I know it's a little blurry, and I'm going to have to kind of angle things for you to be able to see it all. Come on, a little further. There we go. So just let me know if you have trouble seeing, reading anything. I'm going to say it out loud as I work through it too, so you might have to rely on that just a little bit. Okay, if you need more time, unmute yourself and tell me. But if you're ready to go, say nothing. Okay, sweet. All right, here we go. X-intercepts, y-intercepts, but first, let's do minimum and maximum. So right here I wrote min for min. I know it's stuck in the glare, but that says min right there for minimum. And I've got the picture over here so we can kind of see it. Here, let me angle this a little bit so we can get both of those in there. Cool. And I still want to talk to you guys like we're sitting in class. So if you have an answer, just unmute yourself and get it out there. Where is that lowest point? What is that minimum point for this graph? I can wait forever. I want to hear from you. I know where it is. I want to make sure you do. Because when we get to class on Monday, we're going to do this thing for real. We're going to do it for correctness. Okay, your homework, that 1.1 practice, that's just completion and effort. But when we get to class, we're going to do 1 or 2 or 3 graphs, something like that, for real. So I want to make sure you get this.
Is it negative? Is it -2, 1?
Switch those.
-1, 2.
Yeah, -1, because we went left 1, right? Because we started the origin, we went left 1 and down 2. So -1, comma, not 2, but -2.
Okay.
-1, -2. Okay, good. But that's the lowest point, right? Absolutely. That's you scan the graph from the bottom to the top. The first thing you run into is that point right there. Okay, cool. Where's the highest point? Maybe a better question is there a highest point?
No.
No, not with this arrow, right? And I know that could be a little misleading because the arrow is actually like about at the same height as where that last point is, but that's just because sometimes we just run out of space. And that's the direction the angle was going. Not much I can do about that. I would say just none. Right? There is no maximum point at that spot. Because we got that arrow going up and out forever. Okay, cool. X-intercepts. How many we've got? We've got 1, 2. All right, so we've got 2 of them. So here's going to be 1, comma, here's the other one. Which one should we do first? One on the left or the one on the right?
Left.
Yeah, absolutely. So let's name that point first. What is that spot right there where you start at the origin, you go left 2, but you don't go up or down at all?
-2, 0.
Perfect. -2, 0. If you have an x-intercept, really the only number we care about is the x spot, because I know y has got to be 0. So when I hit the x-axis right here at 1, I know that that's the x number, and that the y is just going to be 0 at that spot. Love it. Only one y-intercept is only ever going to be one y-intercept when we're looking at functions, because that just makes it easier to say, here, you got an x value. I only know there's one y value to go with it. So here it is running into the y-axis right there. So let's name that point.
0, -1.
Good. 0 for x. The y is the only number I care about because that's the y-axis going up and down.
Yeah.
Love it. Good, good. And those are our collection of points. These right here are the only numbers written as points, both x and y. Everything else, domain, range, increasing, decreasing, positive, negative, it's either going to be one or the other, either only the x's or only the y's. Okay? And because now we're getting into that interval stuff, right? We're talking about this interval notation, where we're going to use different kinds of brackets to say whether or not we can include the endpoints or not, right? And when we use those hard brackets, right, with the kind of sharp edges there, hard brackets, you know, we do that when the points exist. When I want to actually include those endpoints because it makes sense to include the endpoints. All right, so there's the hard brackets. I wrote the words hard brackets. Points exist. We want to include those endpoints. Now, maybe we don't, right? Maybe I want to use the soft brackets because of stuff like infinity, right? Because that doesn't exist. Or maybe I just don't want to include, right? Maybe I want to just exclude the endpoints because what I'm talking about, it doesn't make sense to include those soft brackets. Cool. And so once we start talking about domain and range, we might have a combination of both. Depends on what we're looking at. So domain is all the x values, and we're going to go from left to right. Those are our x values. So start on the left. Is there a first x value for this graph? What's the first thing on the left side of this graph? What is that spot right there?
Infinity.
Right, you got this arrow pointing out there forever. And since it's pointing to the left and we're talking about x values, right? X has directions, right? We got positive numbers going this way, we've got negative numbers going that way. So let's call that negative infinity as a place to begin. We'll put a comma in between and we'll just figure out where this graph ends, right? It's because just start to end, right? Negative to positive from left to right. Okay, what's that last x value all the way on the right?
5.
Perfect. 5. Now, because it's a negative infinity, we know we can't include that, so I'm going to use the soft bracket. But 5 is a point. It's there. It's circled in. I can go there. I can be there. I can stand at that spot. So hard bracket for sure. Okay. Domain done. All right. Now we look at the range. And these are our y values. And honestly, this is the only one that's y values. Everything else, domain, increasing, decreasing, positive, negative, they're always just x values. So range is the only one where we have to worry about up and down. And this one's just the weird one where we have to look at the bottom of the graph and scan our way to the top and figure out where does this thing start and where does it end. And so it's starting at the bottom, right? We're starting at that point right there. And I just need to name the y value at the bottom of this graph, which is that one right there. And that y value is -2. There's my lowest point. And it's a point, so hard bracket for sure. Is there a highest y value that we should write down? Not if there's no maximum, right? You kind of already set the tone for what your range is going to look like by talking about mins and maxes. Look, your minimum y value, -2, is right there. Your maximum y value, none. There's nothing there. And so that's going to go up forever. And because the positive direction is going up, we're going to call that positive infinity. Okay? Soft bracket, of course, because it's infinity or negative infinity. All right, and that was the old stuff. But what we talked about on Wednesday for the first time was kind of breaking up the domain into smaller and smaller pieces to look at where is it going up, where is it going down, where is it above the x-axis, and where is it below. And so these are our last 4 things that we want to look at. And that's what I really wanted to get out of today. That's why I asked you to be here. So thank you guys for being here. Again, if you haven't put your name in the chat, please do that now so I can take attendance, so I can give you credit for being here. And let's just do these last 4. And then we'll be good to go. And I'll send you on your way. And anybody that wants to stick around and work through like homework 1.1, if you had any questions on that one, or the 1.1 practice for this weekend, I'm happy to do that. Homework 1.1 was just 2 problems. And then, but the 1.1 practice, that one has 4. So you got some work to do there, okay? So increasing, all right, cool. Best way to think about increasing is to just look at where is it going up from left to right. All right, so that's what I wrote there in red in quotations. When you think about increasing, that's what I want you to kind of say to yourself and have an idea in your mind that when you're looking at this graph and you want to break this domain up into different pieces, where is this graph going up from left to right? And it might happen in more than one place, right? We might have a couple different sections. But I always start at the beginning. So I'm going to start way over here. And I'm just going to follow the graph. With my finger, with my eyes, with my pencil, whatever I got. And I'm just going to decide, am I going up or am I going down? And if I'm going up, I'm going to include it. And that's it, because I'm talking about increasing. So if I follow this graph, I'm just going down. And that's not good. So I'm not worried about that. I'm not going to include any of these x values in my answer for increasing. But where is that point where I stop going down and I start to head back up again? Well, it's that one right there, right? That's where that graph takes a turn and starts to head back up again. And so all I need is the x value at that point, okay? And so that x value was -1. But like what we talked about on Wednesday is that at that point, right, at that bottom point right there, when I first step to -1 and I'm at the bottom of that hill, I haven't gone up yet. I haven't started increasing yet, because that frees that moment in time when you're at the bottom of that hill, you're stuck in that valley, you haven't moved yet. I have to take that first step. I gotta move. I have to move my finger. I have to move myself up this graph a little bit for it to count as increasing. And so when we make a choice about whether or not we want to include that first point, when it comes to increasing, decreasing, we never will. Increasing and decreasing, these here will always be soft brackets. Because in order for me to start moving up or start moving down, I have to get myself either out of that valley or over that hill to make it happen. So I'm always going to put that soft bracket in that spot. So soft bracket with that -1. And I just keep going. And I just follow this graph along. And if I'm going up, I'm just going to keep going. Okay, so up, up, up we go, up, up, up we go. And I'm just looking for that point where this graph takes a turn and starts to head back down again. Right? And there it is. Right? There's the top of that hill right there. So I just want to name whatever that x value is. Because in that whole section from here to here, I was going up as I traveled. But as soon as I get to the top of that hill, now I'm no good. Now I can't include that spot as part of this. So what is that x value at that spot right there? That was 2. Comma between them, soft bracket. Okay, and that was kind of what was new for us on Wednesday. Okay. Okay, cool. So from -1, yeah, -1 to 2, we're going up. I hit here, I head back down. And so that's no good. I'm not counting that for my increasing. But is there another point where I take a turn and I start to head back up again? Yeah, right there, right? And so when I list out increasing, I don't want to just name one of them. I want to name all of those spaces where this graph is moving in that direction that I'm talking about. And so it starts again here and then goes up, right? And so what's that x value? That number right there is 3. And then we did something on Wednesday right? When we say, I know it's kind of tough to see, but from 3 to 5, right? Because that graph ended at 5. So I've got 3, 5 there. And soft brackets for sure, because I'm increasing and decreasing. So I've got -1 to 2, soft brackets. And then I've got 3 to 5, soft brackets. But we put something in between them to connect it. Because I didn't want just one or the other. I want both. Do you remember what that symbol was from Wednesday that we put in between those two intervals? Try it out.
Union.
Yeah, nice. And that was just a U. Perfect. Right? So we put a little U in between to mean union so that we've got a way to connect one interval to the next and say, I want all of it. It's all good. I like every part of all of those x values that things are going up. Increasing, done. Okay. Cool. Now decreasing. And that's just the opposite. I just want to go down from left to right. Going down from left to right. And I just look at the picture. And that's the nice part about 1.1 is there's a lot of visual side of things. And I think the visual side of math is one of the easier things to understand because we're pretty visual at this point. And so I just start at the beginning again. I go from the beginning and I say, am I going down from left to right? And the answer to that is yes, right? From the very beginning. But where is the beginning if I've got an arrow way on the left there? Well, there is no beginning, right? There's no first point for me to start counting at. So what should I start counting at? Well, kind of the same thing that we did with the domain. If that's where I'm going to start counting my x's, well, that arrow telling me that we go all the way to the left means that's where I'm going to start decreasing as well. And so I'm going to start at -infinity. And now soft bracket, of course, not just because it's decreasing, but it's infinity anyway. So twice the reason to use a soft bracket there. But increasing, decreasing, always going to use that. And then I just have to decide, looking at this graph, I just have to make that choice. Is there a point where I stop going down and I start heading back up again? And it's right there, right? Kind of where our increasing interval started. That's got to be where our decreasing interval ends. And so what's that x value at that spot? -1. So from -infinity to -1. And then I'm just looking to see if there's any others. And sometimes there's just one. We don't have to have more than one interval where we're doing anything necessarily. But when I look at this graph, I say, okay, going down, 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 down. Okay, up, 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 up. But there's another one, right? There's this space right here where if I just follow the graph with my finger, it's going down from left to right. And so I want to talk about that one too. I want to make sure that in my decreasing set of intervals that I include all of the ones that are going to work. Okay, and so where does that start? Where does it end? It looks like it just goes from 2 to 3. So I've got 2, 3 with the soft brackets around it. And because I've got more than one interval that I like, let's put the U in between for union. So -infinity to -1, union 2 to 3. Okay, increasing and decreasing, done. Okay, and now let's wrap this up. Positive versus negative. Okay, now there's a lot of positive and negative numbers, and it's sometimes can be tricky to know which ones we're talking about. So the way that I like to think about it, because then there's never a doubt in my mind, when we're asked to name where a function's positive, really all I want to know is where is this graph above the x-axis? Positive versus negative, okay? Positive above the x-axis, negative is going to be below. And so things like the x-intercepts aren't going to count for either. And so we're going to see some soft brackets there for sure. I'll even write that down. You can see down here, yeah. When you've got, so talking positive and negative, if you've got x-intercepts where things are going to take a break from either being above or below, we're never going to include those. We're always going to use soft brackets at those spots when we're talking positive and negative because it's neither, right? We're stuck at 0. But there is a chance that we could use a hard bracket. Actually, a lot of times we might use a hard bracket when we're looking at the end points, like the very first point on the left or the very last point on the right. We could use hard brackets. And honestly, the only time we don't use hard brackets is if that endpoint is an x-intercept. So think of this one first. If it's an x-intercept, no way. Definitely not going to use a hard bracket for positive or negative because I can't include that spot. But if it's not an x-intercept, If it's not, and we're just looking at some point kind of floating out in space somewhere else, we'll use a hard bracket type block. Okay. All right, let's wrap this up. Positive. Let's look at this graph. Okay. And I always just start on the left. I look at the first point. Boom. And that arrow pointing up and out forever tells me it's never going to turn back down. It's always going to exist above the x-axis, right? Because there it is. There's the arrow, right? And so I can start counting there. When I look at my positive intervals, I want to include the beginning. And that beginning is at negative infinity. And it's going to take me all the way until I cross the x-axis. That's really all I'm looking for, is where's that first x-intercept where things dip below? There it is, -2. Okay, and I just care about x. So all I need to worry about is what are the x values where this stuff is happening. Remember, just the range is the only one where we're going to list y values. And so we go all the way to -2. Soft bracket, of course, because it's infinity. And soft bracket at -2 because it's an x-intercept. Because as soon as I actually get to -2, now I'm not above the x-axis anymore, but I can get super close. -1, -1.5, sorry, going the other way, -3, -2.5, -2.1, all those I want to include all the way up to just before negative. And then I dip below, right? I've got that section in between there where I drop below, so I don't want to count any of these, but then I'm just looking for that next x-intercept where I head back up. And there it is, right? Because everything above that is all above the x-axis, so I want to include that. And that should be it, right? Because there's the end of my graph. So I'm going to go from 1 soft bracket, because it's an x-intercept, all the way to 5. But look at where that 5 is. It's at the end. And that endpoint is not an x-intercept, so we can include it. And we'll put the U for union in between because we got more than one that does the job. So for our positive intervals, we're going negative infinity to -2. Soft bracket for both. 1's infinity, of course, soft bracket. -2 is an x-intercept, so of course, soft bracket for positive versus negative. And then we'll go from 1 to 5. All right, and then last one, and we're done. All right, that negative section, but that just exists in between here. I have this nice continuous space. There's no breaks, there's no gaps, and there's no other space in this graph that exists below the y-axis. So when I look at this and I'm trying to figure out, okay, how many intervals do I really need? Well, if I can just kind of sketch that little section below the x-axis without having to pick up my pencil, then I just have the one section I have to worry about, and I just name the x values where it happens. And so I just say, okay, from left to right, so from -2 to 1. And just have to make a choice as to whether or not I'm going to include those endpoints or not. And the first thing I ask myself is, are those numbers x-intercepts? Because if they are, soft brackets. Yep, -2's x-intercept, and so is 1, and I'm done. Okay, so there you go. That's what I wanted to give you. That was basically yesterday's lesson for cohort B, and I just didn't want you guys to be any more behind because we lose next Wednesday. Right, I mentioned that hopefully this past Wednesday, but if I didn't, seniors are taking their SAT that they lost their chance to from last year. So there's a day dedicated to those seniors taking the SAT. And so us in cohort A, we stay home. Unless you're a senior, you are not coming to school next Wednesday, okay? It's a remote day for you. It's a remote day for cohort B, of course, and every senior is taking the SAT on that day, all right? So just a little heads up, and I'll keep reminding you as we get closer to it. But you're good. If you are happy with this and you don't have any questions, you've got homework 1.1 that should have been in, but you also have homework, 1.1 practice that's due Sunday before midnight. That's 2 on the front, 2 on the back for you to look at, okay? And I'm happy to work through anything. I'm happy to answer questions that you've got. But if you're good and you drop your name in the chat, you are good to go. Have a good weekend, everybody. I also put in some grades for the quiz, all right? So check those out. On Infinite Campus, those are in general, things went really well. So, and if you have any questions, just let me know.
Yeah, I have a question. You said you were recording this meeting?
Yes.
Do you upload this to Canvas?
I do. So on Canvas, there's in the menu on the left-hand side where it has modules and assignments and home and stuff, there's something called Pages.
Okay.
So if you click on Pages, it'll take you to the home page. But at the top of the homepage, there's a button that says View All Pages.
Mm-hmm.
To click on that, there's a link for the Google Meet recording links. Because I'll take this video, and once it's processed, I'll upload it to YouTube so I can get it out of my drive because I'll run out of space really quickly if I leave it on drive. So I'll put a YouTube link on there probably in about the next half hour, maybe 45 minutes. It should be sitting there. So you can go back and rewatch and check out anything you missed.
All right. Thank you.
You're welcome. Have a good one.
Thanks. You too.
Okay, so I know that you wanted me to stay on here to like kind of ask you some questions and stuff.
If
But
you have any.
Yeah, but I think I'm pretty good. And also, you know, Katie Connard, my cousin.
Yeah.
She was like helping me a little bit, like with
Good.
like understanding what they are and stuff. So I think I'm pretty good overall.
Great. If you're good and you feel like you have a pretty good grasp on all this stuff, then I just wanted to be here in case you did have any questions about it. But if you feel like, you know what, I think I got it, then you should be able to do homework 1.1 and the 1.1 practice and feel pretty good about it. And those are on Canvas, so you can just kind of work through those this weekend, see how you feel. If you feel good about them, submit them, and I'll take a look. And if I have anything that I think we need to talk about, then I'll reach out and let you know. But if things look good, then you'll just see the 5 out of 5 get dropped in Infinite Campus, and you'll be all caught up.
Okay, cool.
The only thing, Abby, I feel like there might be something here. Let me stop recording.